Hello everyone. In today's lesson, we are going to solve some questions which are related to the index laws. I have already created some videos related to this index laws and explained each law in detail. But today my main focus will be on solving the questions. Okay. See, one thing is you know the law or you know the concept, that is one thing, but how to implement it and what kind of questions can be there, solving them is most important thing. So today we are going to solve many questions related to index laws and small but important facts about the index laws we have to learn in today's lesson. So if you look here, we can see one question is given as 3 raised to the power of 1 times 9 raised to the power of 1 times 27 raised to the power of 1. Now the question is, I told you many laws and I focused on when I was explaining you first law of indices, like a to the power m times a to the power n is equals to a to the power of m plus n. And I kept saying that the bases should be same, bases should be same. But now what if the bases are not same? Though it is not applicable every time, but most of the time this is applicable. So for example, in exam, this question comes, solve it. So it doesn't mean you need to multiply everything. You have to write it like a power. As a power expression, you have to write. Let's say the question comes, this is given, and write it as a single power expression. This whole thing you have to write as a single power expression. So now what should we do here? We cannot apply this law. So what we need to say is, look carefully. Here we have the base as 3. Here we have the base as 9. And here we have the base as 27. And if you closely look here, we can see that 9 can be written as 3 times 3, or I can say it is 3 square. So what I will be doing, I will replace my 9 with 3 square. Same way, 27 is 3 times 3 times 3, which can be written as 3 cubed. So as I see, now it is going to be very simple for me. I would change the basis 9 and 27 in the power of 3. So it is 3 to the power of 1 times 3 to the power of 2 and whole raised to the power this 1 times 3 to the power of 3 and whole raised to the power 1. Now all the bases are same and apply the property of multiplying the two bases, the two powers. So we got 3 to the power of 1 times 3 to the power of 2 times 3 to the power of 3. Because when you have a power expression and then there is another power of it, so it will become a to the power of bc. The powers get multiplied. So here it is 2 times 1, 2, and 3 times 1 equal to 3. So ultimately what we are going to get over here is, we got 3 to the power of 1 times 3 to the power of 2 times 3 to the power of 3, which means it is 3 to the power of 1 plus 2 plus 3 as per the law of multiplication of in indices. So it will be 3 to the power of 6. So we should know, if sometimes bases are not same and question will always come in such a way that you will be able to express all the bases as a same base. Okay. So now second question, we have 4 cubed times 2 cubed. Again, I see that here the bases are different. Now this question can be in two ways. First is, if you have a to the power of n times b to the power of n, and they are in multiplication, so I can write it ab and then whole raised to the power of n. So here I can do it like 4 times 2, because the powers are same, then only you can do it. So 4 times 2 and whole raised to the power of 3, and which is 8 to the power of 3. Second method is, we know that 4 can be expressed as a power of 2, which is 2 squared. So I will replace 4 cubed is equals to 2 squared to the power of 3, which means it is 2 to the power of 6. Therefore, now I'm going to write this expression 4 cubed times 2 cubed as 2 to the power of 6, I got it from here, times 2 to the power of 3, which means it is 2 raised to the power of 9. Now, if the question is asked that you have to write this whole thing as a power of 8, the a to the power of b, or if you have to write it like 2 raised to the power b. So this is a way to solve the question. Okay. Next question comes 8 raised to the power of 3 times 4 raised to the power of 10. Now the question is here, I cannot express 8 as a power of 4. See, some of the students, they will do mistake, they will write it is 4 times 2. No, we are not supposed to write as a multiplication. We have to write as an exponent, power of. So what I can do here, neither I can express 4 as a power of 8 or 8 as a power of 4, but I can see that 8 can be expressed as a power of 2. 8 is 2 cubed and 4 is 2 squared. So that means if I express 8 and 4 as the powers of 2, so I am going to get a common base. So I will continue this way. So what I am going to write here is 2 cubed, that is 8, and whole raised to the power of 3 times by 2 raised to the power of 2 and whole raised to the power of 10. So this is equals to 2 raised to the power of 3 times 3, which is 9, times 2 raised to the power of 20, and which will be 2 raised to the power of 29. Now, one of the most important thing here is, which is very, very important, and that is that you need to be very careful which law you have to apply and how you have to solve. You have to write here which properties you are applying in the exam. It will be very helpful because when you have to locate the errors, then it will be easy for you that if you have applied some properties in a wrong way or something like that. So elaborate your answers properly. Okay. Now the next comes, for example, we have next question is, let me make it here. Okay, next question is 16 raised to the power of 2 times 8 raised to the power of 2 times 4. So how we can solve this question? Very easy. Again, I see we have 8, 16 and 4. We have to express all of them as a single power, like single base, same base. So I can say 16 is 2 raised to the power of 4. It is not so hard to remember. When you will practice, it will be easy for you. Another thing, which the questions which I'm going to explain, because my main focus to explain is making the same basis. Later on, you will see these power values, they can be of the like variable form also. Okay, I will explain those type of questions as well. So 16 is 2 raised to the power of 4, 8 is 2 raised to the power of 3, and 4 is 2 raised to the power of 2. So now we can express all of these as a common power or common basis. 2 to the power of 4 raised to the power of 2, 2 cubed raised to the power of 2, and 2 squared. So now apply the property 2 raised to the power of 8 times 2 raised to the power of 6 times 2 raised to the power of 2, which is 8 plus 6 plus 2, and it is going to be 16. 2 raised to the power of 16. Okay. Next question is 125 cubed over 25 squared times 5 cubed. Now here also we have different bases, but as I know, 125 can be represented as 5 cubed. 25 can be represented as 5 square. Remember, you have to write as a power form, like a to the power b, a power expression form, not as multiply. Okay, no, don't write 25 as 5 times 5. You have to express it like 5 square. Now replace this value. So 125 is 5 cubed and then whole cubed over 25 square means 5 squared the square and times by 5 cubed. Now first we can solve the numerator. So 5 to the power of 9 times 5 cubed over 5 to the power of 4. If I solve the numerator, it will be 5 to the power of 12 divided by 5 to the power of 4. Now these the power expressions are in division. So I can solve them 5 to the power of 12 minus 4, which is 5 raised to the power of 8. If the powers will be smaller, like after solving like 5 to the power of 3, so you can show it like 125 also as a final answer. But if the numbers are bigger, then you can leave it like this as well. Okay. So there is one more question, number 6. I am leaving this question for you. You can try. Now the same concept, like we have learned how to make the bases as same. Now what we can do here is, we can learn the concept of solving the equations. For example, the question is solve 9 to the power of x equal to 3 to the power of 6. As I see, the bases are not same. So what I will be doing, I'll try to make the bases same. So 9, I know we can write as 3 squared. So I will write 3 squared and whole raised to the power of x is equals to 3 to the power of 6. Now I will apply the multiplication law of the powers. So it means 3 to the power of 2x is equal to 3 to the power of 6. Now there is a very important thing. If the bases are strong and in an equation on the either side bases are equal, not strong, but they are equal, then you can equate the powers. And that was the reason I made the bases same. If bases are same in an equal to on the both sides, we can equate the exponent values. So 2x is 6, which means x is equal to 3. Okay, this way we can solve the equation. Next question is 16 to the power of x is equals to 2 raised to the power of 64. So in this question, one side is 2, one side is 16. And I know that 16 is 2 raised to the power of 4 and whole raised to the power of x is given here. So I will write as it is, and it is equal to 2 raised to the power of 64. So this means it is 2 raised to the power of 4x is equal to 2 raised to the power of 64, which means because the bases are same and there is an equation equal to sign here in between the two basis power expressions. So now I can equate the power. So 4x is 64. To find x, we will divide both sides by 4. So x is equals to 60. Okay. Now the next question is 8 to the power of x equal to 4 to the power of 6. This is the same way we can solve. Now one more question where we will be getting an expression in the powers. So I solve one of these questions now, and remaining question like 1 or 2 if I leave, that you can try on your own. Okay. So the question is now 4 to the power of 2x plus 1. I'm going to explain the last question, and equal to 8 to the power of 2x minus 1. So here again the bases are not same, but as we learned that we can represent both the bases as another base. So 4 is 2 square whole raised to the power of 2x plus 1 is given here, and 8 is 2 cubed and whole raised to the power of 2x minus 1. So here if I multiply the brackets, so it is like this because it is more than one term, so you can consider it this way. So 2 will be multiplied by 2x, which is 4x, and then 2 will be multiplied by 1. So 2. Consider it is like this way. Okay. And on the other side, right side, it is 2 raised to the power of 3 times 2x, which is 6x, and 3 times minus 1, which is negative 3. Now, because the bases are same, so the powers we can equate. Now we have 4x plus 2 is equals to 6x minus 3. Now the question is how we can solve it. We have variable on both the sides. Now there are multiple ways to do this question. What I usually do, we have 4x plus 2 is equals to 6x minus 3. This is the bigger number 6x as compared to 4x. If I compare the variable terms, one is 4x and one is 6x. I will break this 6x into 4x plus 2x. By doing so, what will happen? The 4x and 4x will be cancelled because they are both equal and on the opposite sides. So what I am left with is 2x minus 3 is equal to 2. Now this is a two-step equation. So first I will add 3 on both sides. So 2x is equals to 5. And then slowly we will be getting divide by 2. So x will be equal to 5 over 2, which means x is 2.5. Or you can say 2.5. If your number is going to be a terminating number, rational number, then you give answer in decimals. Otherwise, the best way is to give the answer in the fractions, or it depends upon how the question is being asked in the question itself. Now, these are the some questions, samples, which I have thought of explaining because I feel just only explaining the questions and giving example just related to particular kind of index laws is not sufficient for my students, so I have made this video. I hope you already you like this video, and these equations, how to solve it, I will come to this point also. I will make some videos on this linear equations part also, how to solve them, because many students, they find it really tricky. And you will see like 35 to 40% of the paper, they might use this part in, not directly, but in many of the other topics also. So I hope this video will be useful for all of my students. Thank you so much. Have a nice day. Bye bye. Take care.